everyone, I hope you are doing good. So today in this DSA series we will take a new DSA question, and that is burning tree. This is the question which got recently asked in one of the interview, so that is the reason why I am taking this question today. The question, so first we will understand the question with multiple examples, then we will try to solve this. We will think about the solution algorithms which can be applied to solve this problem, and then I will explain whatever the algorithm solution I am using, and also I will show you the C++ code which I have already added for this problem. So let's start with the question first. So here in this question, a binary tree will be given, a target node will be given, and we have to determine the minimum time required to burn the entire tree, right? If we set the fire on the start node, and the condition is given here is in 1 second. In 1 second, what will be burned? Like its left child, its right child, and its parents. It means all the connected nodes to that node will be will catch fire in 1 second, or you can say the fire spreads from its related nodes or connected nodes in 1 second. That is what is given in the question, right? And here one more condition is given. The tree contains unique values, so the whatever the target value will be given, that will also be unique, because it is also explicitly mentioned here the tree contains unique values, so you will not find any duplicate nodes in the tree. I hope it is clear. Till now it is clear. Let's take some examples to understand it clearly. So here the first example is given, right? The tree is 1, 2, 3, 4, 5, 6, 7. This is the given tree, right? And here target is 2. So what we have to do? So basically this is 2. So here, from here, the fire will start, right? So at 0 second, this will catch the fire. At 1 second, 4, 5 and 1 will catch the fire, right? Why? Because it is here mentioned that here in 1 second, right, the fire spreads from a node to its left child, its right child, and its parent, right? So the connected nodes will catch the fire in 1 second, right? So basically the spreading will take 1 second to its connected nodes. So here 1 is connected to 2, 5 is connected, and 4 is connected. These 3 nodes are connected to the 2 node, right? This one, right? Which got catch the fire already. So here in at 1 second, the nodes 4, 5 and 1 will catch the fire, right? At 0 second this will catch. At 1 second this one, and this one. At 1 second these 3 nodes will catch the fire, right? The next 2 second, right, plus 1 second, it means at the 2 second, because 4 is nothing having, parent is already burnt. 4, 5, it does not have any child, and the parent of 5 is 2, that already got fire, right? So and for one node, this one, so from here after 1 second this 3 will catch the fire, right? Because the one the left child already got the fire, and the right child is not yet burnt, right? So in 1 second, in another 1 second, this will catch the fire. So that is why here see at 3 second, so sorry, here at 2 second node 3 will catch the fire, right? So 1 plus 1, that is 2. At 2 second this will catch the fire, and after another 1 second this 6 and 7 will catch the fire, right? At 3 second node 6 and 7 will catch the fire, right? At 3 second here. So here total time is 3 second, right? So here total will be 3 second, and that is the answer. That is what the requirement of the question. Let's take another example. So here see the target is 10 and this is the tree, right? So this is your target node, or you can say this is the start node, right? So at 0 second, this will catch the fire, right? This will start at 0 second, right? Now its connected nodes are 5 only, its parent only, it does not have any child, correct? So at 1 second, 5 will catch the fire, correct? I hope it is clear, because the fire spreads from node to its connected nodes in 1 second, right? So at 1 second this will catch the fire, 5 node, and another 1 second this 2 will catch the fire, right? So it will be at 2 seconds, right? At 2 second that 2 catches the fire, this will catch the fire. Now another 1 second, the connected of 2 is 1 and 4, so 1 and 4 will catch the fire in another 1 second, so that will be 2 plus 1, that is 3. So at 3 these 2 nodes will catch the fire. At another 1 second, the connected of 1 is 3 only, 2 already got the fire, and for 4 connected are 2 and 8, 2 already got, and 8 will catch the fire in another 1 second, right? So in another 1 second, this 8 will catch the fire at 4, and this 3 will catch the fire at 4, right? At 4 second, this 3 and 8 will catch the fire, right? At 4, 3 and 8 will catch the fire, right? I hope it is clear, because in another 1 second the connected nodes will catch the fire, right? And now 7 is still remaining, so in another 1 second this will catch the fire from the 3 node from here, right? And 8 will not have any connected nodes, right? It is connecting to 4 only, 4 already got the fire, right? So no need to worry about that. So now the total time, now all the nodes are basically burnt, right? Caught the fire already. So now the total time is here 5 seconds, right? So to burn entire tree, this entire tree, 5 seconds basically will be required. So pause the video for a second and think about the solution, think about the algorithms which can be applied to solve this problem. And if you find any different algorithms than whatever I will discuss, then please comment below the video, so that we also get benefited by your solution, by your algorithms. So here what would be my approach? My approach would be, first I will find the target node. So first I will find the target node. Then second, what I will do, I will basically create a map of the node and parent node, because from, for example, this node, so we can go to the left hand child, right, that is our structure, but we cannot have any link from node to its parent node, right? We do not have this link. We have the link of node to child node, left or right we can go, but we cannot go to the parent. So that is why, and here if this node catch fire, this 2 node catch fire, then all the connected nodes will catch fire after in another 1 second. But how can we go to the one, right, that we cannot go? So that is why what I will do, I will create a map of a node and parent node and its parent. So that is the two things I will do. After this what I will do, so once I have this thing, now I know that from where I have to start, and the parent node map also I have, right? So now what I will do, I will go and start from here, right? And for this one, what like, if you know the level order traversal, right, then that would be very easy. Or you can say I will burn the tree, right, using level order like technique. So let me show you the C++ code, and then I will also do the dry run for another example. So see here, this is my main function, min time. So I have to calculate the minimum time, right, to burn the entire tree. And I got the target node here, target node value basically, and the root node of the tree, right? So now I will create a P map, parent map, right, node and parent map. It is unordered map, right, because I don't care about ordering. Then I will take a queue, because I'm basically creating this map and finding the starting map using the level order traversal, right? So because that is the iterative one, so here I'm using the level order, correct, and I will I will store this starting node into the start, this variable, right? Here creating a parent child map and finding the burn start node. So I am using while loop. If you don't know the level order traversal, please check out my channel. There I have already uploaded a video for level order traversaling, right? This technique I have explained there in multiple times and in detail there with multiple examples, so you can check that out. Here you can simply understand, we take, and then why we need queue and why we need this while loop and all those things, right? So here this queue, I'm doing the level order traversal, nothing else. And here I have added the one more condition to find the start node. If node arrow data is target, the value of the node arrow data, the node is equals to the target, it means this is the starting node of the tree, from where I have to start the burn or fire, correct? I have to start the fire from this node. So this is the extra condition I have added. And here what I am doing, P map and node arrow left and then net, right? So here for each and every node, I am basically putting the parent node here, or you can say creating the relation between node and parent node in this map, right? In this P map, parent map, correct? So for example, this one here, I am coming from here, so one node, right? So one I will take out in the node, and then I'll take out from the queue here, and node arrow data is target, no, it is no. So I will go to the second if block here, node arrow left, yes, it is there. So node arrow left, the parent of node arrow left would be node, right? So this is node, right? And this is node arrow left, this one is right, and this is right. So node arrow left, the parent of node arrow left would be node, correct? That is what I am doing here. If node arrow left is not null, it means there is a node, child node. So node arrow left, then the parent value would be node, and here for node arrow right, the parent value would be node. So that is what I am doing, and I am creating the map of the node parent node relations, right? So here it would be, the map would be like 1 null, right? Nothing, no parent is there. Then 2 1, then 3 1, then you can say 4 2, 5 2, then 6 3, and 7 3. So like this I will get a map, correct? I hope it is clear. Now going down here, so now I have let me minimize this one, right? So now I have the parent map, I have the starting node, right? And starting node is this one, right? I have this one, and I have the parent map here, right? I have already explained this one. So now what I will do, I will check if the starting node is null. It means I did not find any starting node, or you have given a wrong value, right? In that case I will return and say 0 seconds, right? After this what I will do, I will start burning the tree. If I found the starting node, then I can start burning the tree. And for that what I need a queue here, right, to use, because I will use the while loop here, and I have a map to maintain the status of that node, right, if it is already burned or not, right? So node and boolean, right? So that I will need a map here, and I created one variable to count the time, correct? So I will start by pushing the first node, starting node, into the queue here, and then I mark it as a true. It means it caught the fire already, right? True. And then I will basically run this while loop until queue is empty. So now see here, the fire, I am taking this fire flag here because if I, for example, I have these three nodes, right, and these three are already burnt. In that case, no need to increment the time. So to increase the time, I am using this flag boolean here, fire, right, and initially I am taking it false. If it becomes true, it means one of the node got fire. So for example, this one, right, and we are here at this it is not having anything, so then no need to increment the time, correct? So that is why. And for example, these three nodes, right, 1 4 and 5, this will catch the fire parallelly. So instead of incrementing 3 times, I can say I will increase only 1 second, right? So for that I have taken here fire flag. Initially it is fire, and then I will take the size of the queue, how many nodes are there in the queue, right? Because those nodes will be burnt parallelly, right? So for see here, starting we are from here at 2, right? But now the size of the, and then if from here these three nodes will catch the fire parallelly, 4 5 and 1, right? So in queue 1 4 and 5, these three 4 5 and 1, these three will be there, right, in the queue. In the queue 4 5 and 1, these three will be there, right, after this one, correct? And then the size of this would be 3 here, and these three nodes will be burnt parallelly. So that is why I am doing here for left child, for right child, and for parent, right? And once these are done, then only I will say if fire count is true, if one of them caught the fire, right, or all of them caught the fire, then only I will increase the count here by 1, right? I hope it is clear, uh, right? So that is why I am using here this for loop, right? And I will do this process for all the entire tree, and then I will return the count here, and then what I will do, I will return the count, right? And that would be our answer. So let's do the dry run, correct? From here I have to start, right? Now I will take a queue here, right, bq by this burning queue. So for burning queue, what I will do, I will take a queue here, right? This is my burning queue. If it is empty, then only I will come out from this while loop. So initially in queue I will put the start node, right, 2, and I will mark this as a basically in map I will do that, but here only I will mark. So for example, here what I will do, I will mark it true, right, and my count is my count initially 0, right. Then what I will do, I will take a size of this queue. So size of the queue is 1, right. Size is 1 initially, it means this one node will only go and catch the fire, right, at 0 second. So at 0 second, see, at 0 second 2 will catch the fire, right. And then in another 1 second what I will do, I will go and check, and I will take this out, this 2 I will take this out, right, 2, and I will check the left node of this 2. So left is 4, so I will put it inside the 4, and I mark it as a catch true. See here, I will mark is true, right, in the binary map, and I'll put it inside the queue, binary queue, and I will say fire is true, right. I will say fire is true, correct. And I'll do the same thing for right. So right, I will mark true, and I'll put it inside the queue, so that is 5, right. And I'll do the for parent. So for pmap we have already pmap, and the node is 2. So the parent of 2, see here, parent of 2 is 1, right. So I'll check for 1 here. So 1 is not null, right, it is there, parent is there. And then I will check, it is marked as true already. No, it is not marked as true. Initially by default it is false, right. So I will say this will also catch the fire. So I will put this also inside the q1, correct, and I will mark is true here, right. So now at 1 second, and now I will say, and right, and then the size is 1 only, so I becomes 1 now, I plus plus 0 to 1, right. So I will come out from this loop and say fire is true, yes. So I just increase the count here. So I will increase the count to 1. So at 1 second this 4, 5 and 1 will catch the fire, correct. I hope it is clear in one iteration. So now let me take this out 2 here, right, and this node also, and this fire status also, right, and this size also. Now I will go up and check this binary queue. This is burning queue is empty. No, it is not empty. Okay, fine. So now reset the fire button here, right. So this fire flag, this is false now. Then the size is basically 3 now. It means these 3 nodes will burn parallelly, correct. And then I will take one node out from the queue here. See here, I will take one out, bq front, that is 4, right. So what I will do, I will take one out. So here I will take this out, 4, right, and I'll check the left of this one. So the left of 4 is null, so we will not go inside this one. The right of is also null, so we will not go inside this one, right. And then I will check the parent of 4. So parent of 4 I will find from here. So see, parent of 4 is 2, correct. And so 2, then the second is the 2 is already burnt, yes, it is true, right, it is true. So we will not do anything, we will not go inside this one. Now we will go next to this for loop. So I will take out this 5 here, right, I plus plus, size is 3, I is here basically 1, right, correct. So now this one, and here then I will take this out 5. So this is 5, and I'll take the left of 5. So here this, see, node arrow left, 5 of left is null, so we will not go inside this one. Right is also null, we will not go inside this one. The parent of 5 is 2, right. So now it is not null, okay, fine. It is burnt, or yes, it is true, it is burnt. So here I am adding the negation also, right. So this condition will be false, so we will not go inside this one. And again I will go to this I plus plus, I becomes here 2, correct. So 2, so and then size is 3, so 2 is less than 3. So just go inside the for loop again. So let's take out this 1 here, 1, correct. And I'm parallelly popping it out from the queue, right. So and then here one arrow left, is there, yes, but it is already burnt or not. It is already burnt, it is marked true, correct. So this, for this I will take a node and status map, boolean map, right? Not pointer comma boolean map, unordered map, right? So that is what p map is there, burning map. And then this is false, so this condition is false, right? Then node arrow right, yes, it is there, node arrow right is there 3. And this is burnt, no, it is not burnt, so we will not go, we will go inside this one. Now this time we will go inside this condition right one only, right? Left is already burnt, so right, and here we will say fire is true, right? Fire is true, it means the this node will catch the fire, node right will catch the fire, right? So it is true, and we will put this node inside the queue here, and that is 3. So we will mark push inside the queue here, right? And then we mark this true here, and right, for this one, and then this is true now, and then we will check for the parent of this one, right? So parent of one is null. See here, parent of 1 is null in the parent map, correct? So we will not go inside this one, and we will come here, and I becomes 3, size is also 3, so we will come out from this for loop, right? And then we will check the fire flag. So here fire flag is true, right? So we will increase the count here. So now our count becomes 2. See here, at 2 seconds this 3 will catch the fire. That is what it means, right? See here, at 2 node 3 will catch the fire, because 3 is only there in the queue, right? So let me remove this one, because we have already popped out these nodes, right, here, and then reset this one also, correct? So at 2 this one, so now size becomes 1 again. It will go and check this burning queue is empty. No, it is not empty, it is having one node, right? So fire set it to false again, and size becomes 1 here, right? And I will go inside this one, I is 0, 0 is less than 1, so we will go inside, and we will take the front of the queue, that is 3 here, right? And then I'll take it out from here queue here, and then I will check the left of the this node 3. So left of 3 is 6, right? It is there, it is burnt, no, it is not burnt, right? So we will go inside this if block, and we will mark it true in the map, right? And then I'll put this node into the queue here 6, I'll put into the queue 6, right? And then I'll make this fire flag to true, right, because this node got the fire. Then I'll go to the right of the 3. So right of the 3 is also not there, right of the 3 is also there, and it is not yet burnt, right? So let's go inside this if block, and here mark it true, and then push this into the queue here. So 7, let's put it, and then fire flag is already true, yeah, so that is fine. And then go for the parent of 3, so parent of 3 is 1, right? Here from the parent map we can check parent of 3 is 1, so 1 is there, but it is already true, marked true in the status map, right? So we will not go inside this if block, and we will go up, and I becomes 1, and the size is also 1, so we will come out from this for loop and check fire flag is true, right? So we will increase the count here, so now count becomes 3, right? Now count becomes 3, and now what you can say, at 3 seconds this 6 and 7 will catch the fire. At 3 seconds node 6 and 7 will catch the fire, because these two nodes are there in the queue, right? So now let me remove this one here and reset this one, correct? And now see here, size is now burning queue is not empty, right? Two nodes are there, correct? So now I'll reset this fire to false, right? And burning size is 2, and here node I'll go inside this loop here, because I is 0 and size is 2. So let's take the front, so let's take out 6, right, and take it out from the queue here, and then I'll check for the left here, right, left. So left of 6 is null, so we will not go inside this one. Right of 6 is also null, so we will not go inside this one. And then parent of 6, so parent of 6 is 3, 3 is already burnt, right? So we will not go inside this one, correct? And we will go up here in for loop, so I plus plus I becomes 1. Now 1 is less than 2, right? So we will go down, and then we will take out the front node from the queue, so that is 7. Let's take it out, and then we will check and take it out from the queue, right, from here, And then for the left node, 7 of left is also null, we will not go inside this one. 7 of right is also null, right, we will not go inside this one. The parent of 7 is 3 from here, parent map, right, 3. So 3 is already burnt, so we will not go inside this one. And then we will come here at the top of the for loop, and I plus plus I becomes 2, size is also 2, we will come out from this one, and here we will check the fire status. So fire status is false because initially it got false, right, we just set it and it did not update because there is no remaining nodes now, right, to be burned, right. So it is false itself, so we will not increase the count here. And then once we are done, then and our queue is also empty because 6 and 7 got already popped, right. So let me remove this one here. This is already got popped out from the queue. So now queue is empty, right, queue is empty, so we'll come out from this loop, while loop here, right. And after this, what I will do, I will return the count here, right, I will return the count, and our count is 3, right, you can see our count is 3 here. So this is our answer. So I hope you are clear with the question, you are clear with the solution algorithms, whatever we have discussed, right. In this algorithms, in this solution, what you have to keep in mind, first you have to find the target node, right, target node you have to find, and you have to create a parent map, right, parent map, right, which is used while burning the tree. And then for this and this, for these two, you can use the level order traversal, correct. And then what you have to do, then you have to burn the tree, right, burn the tree, right. And for this also we are using same level order technique, right, the queue and the while loop, right. For this also we are taking what, queue and while loop, right. And in this we are using for loop for parallel burning. These are the points which you have to keep in mind while solving this problem, right. If you know the level order traversal, then this question is very easy for you.